Okay. When I say time and space complexity, people always miscalculate with the machine. For example, if you are having two machines, one is Mac, other one is Windows machine. Okay. And you run same program on Mac and Windows. What do you observe that in Mac it is taking less time compared to the Windows? So is it the code fault or what is the issue?
No, for the Mac, they are using the. No, I don't know.
So basically Mac is using the high processor, right? M1 chip kind of.
Okay.
And Windows might
Yes.
be having low processor compared to the Mac. And since the processor is
Okay.
high, that's why your program executed fastly. Correct?
Yes.
So is it the issue of the program or is it the issue of the operating system or the configuration of
Operating
machine?
system.
So basically, it's not the issue of the program, whatever you have written. It's basically the issue. We can't call it issue as well. If the processing is fast, your code executed fastly. But the algorithm itself takes how much time? We'll look into that one. Okay. And how much space does it take? Both the things we'll cover. Okay. Because people have a very
Okay.
misunderstanding regarding this time complexity. Sometimes they compare with the processing one, which is not in the case. So let's start. Okay. Now, why does it matters? There are few things that we always need to take care. First is the speed.
Mm.
For any program, you need to take care three things: speed, scalability, and memory. If any program
Okay.
is doing best in these three parameters, it is good to go. But if you are lacking in stability but going with the speed, again, it is not long-term program or it's not a scalable program. So no company or industry would require such kind of program which cannot be scalable. Because in future you are not
Okay.
the only one who is going to program. Number of more people will come and work on it. Along with that, customers will also grow. So scalability should be there. So if I talk about the speed, a bad algorithm can take hours on a large data. A small one or a good one take few seconds. Basically, whenever the input increases, how quickly your algorithm solve that input. If the algorithm is not good, it may take hours to solve depending upon the input. Because you
Okay.
can have huge amount of customers, isn't it? And huge amount of customer means huge amount of input. Is your algorithm handling that much amount of inputs and how much time it is taking? So that determines by the speed. Second is scalability. Again, code that works for 100 item may get failed for the 1 lakh item. It basically the test cases. Like 10 test cases it passed, but when I write the 100 test cases, all the edge cases, it failed over there. So again, it is not scalable. And when it comes to the
Okay.
memory, when solution crashes your program by using too much of RAM. Your RAM is always less than your hard disk and all. Your RAM is a temporary memory, okay, where your code
Yes.
getting executed. If your code is somewhat taking huge amount of space for the execution purpose, then it is going to crash or it will hang. Basically, it happens in the infinite loop. What happened? Your memory get crashed not because of the infinite loop, because it takes all the spaces. Since it is infinity, so it has no limit for the memory. So no matter how big your RAM is, it is always going to crash at some point of time, right?
Yeah. Good.
So interviewers look for the complexity analysis test. In every major tech companies, you will find once you write the code based on the problem that they have given, they'll ask you what is the time and space complexity of the program that you have written. If you said it, then they'll ask you to optimize your program and now tell me what is time and space complexity, unless you reach the best possible complexity. Okay.
Okay.
Now we have discussed more on complexity. Let's see what is complexity. Before that, two things you need to know: priori and post priori. Have you ever heard this name?
No.
Okay, so these are kind of analysis we do with the code. What does it mean? Priori basically means prior. Prior to what? Prior to system execution. Before system execute your algorithm, you should estimate the time and the memory management. It happens that whenever you go for buying something, you have the estimated cost. At least this much I'm going to have it. And after that, when you actually spend those, you can see how much it compared to the estimation it performed. So post priority is basically the total calculation of the algorithm after the execution done by the system. So this estimation is done by us. This estimation is done by the system. But the best analysis considered to be the priority instead of post priority. Why? Because you have a prior idea how much time and space it is going to take. And that is what everyone is worried about. Because once you executed the program and then it is hanging, crashing, then it doesn't make sense. People will ask you, why don't you test your code or did any estimation time and space complexity of your code? So those things you need to undertake while solving any kind of a question. The estimation one, how much estimate time you are going to take for your algorithm to get resolve the problem. Got it?
Yes.
Okay. And when it comes to the CPU computation part, okay, there are basically two parts. One that CPU performs based on the instruction or the execution, how much it takes the time. So CPU computation basically refer to the task performed by the CPU or the instruction executed by the CPU. And the second part is the main memory space, which comes under your RAM. So temporarily store of data and the instruction that CPU needs. So CPU execution, how does the CPU get the idea that what to execute? This idea comes from the RAM. RAM actually stores the data and the input that you provide and send those input to the CPU. CPU then process it and send it back the output to the RAM, and then we see it on our console. Got it?
Yes.
So in computer language, in logarithmic language, in general, you have this main and temporary memory storage. Like main is your hard disk and temporary is your RAM. But in algorithmic world, your main memory is your RAM. We do not have to do anything with the hard disk right now. Okay. All your code while execution is going to run under or store under your RAM. Okay. Understanding the time complexity. Estimation of the okay. See what time complexity actually means. How much total CPU computation required? We know what is CPU computation. Instruction executed by the CPU. Okay, or the task performed by the CPU. But it is calculated using this formula. Time complexity of an algorithm is equal to the total number of CPU computation. I mean, how much CPU core is involved in solving your problem. Again, that depends upon the frequency of your count, input count. Now, what is this input count? Sum of the frequency count of each instruction of an algorithm. What is this frequency count? Any idea?
Frequency count. No.
What does frequency means?
Frequency means CPU gives the some response to RAM and RAM gives to response to the CPU. How fast they are doing it?
Correct. How fast and how much amount of data we are transferring. So frequency is basically the number of times instruction is executed. Like if I have given 5 inputs, for 5 inputs, how many times CPU is going to execute the program? 1 time, 2 time, 3 time, 100 time, like this. Okay. So time complexity, if anything, if you have to correlate, what is time complexity of an algorithm? Number of times instruction is executed by whom? By CPU. Got it? Any questions till here?
No.
Okay. understood. No, time complexity is basically deal with the number of time your instruction is getting executed. Now this instruction is being ranked over it. But before going ahead, okay, let's start from here and then we'll come back to that previous slide. This time complexity always denoted by this O notation, which we call as big O. Okay, you need not to say big O. Just if interviewer asks you what is the time complexity, just say O of 1, O of 2, O of 3, O of n, and whatever available. Let's start with O of 1. Let's understand when we say that O of 1 is the actual value. So suppose this one. See, I'm having one numbers, which is basically a list, and what I'm printing, the index number 2. So what will be the output?
Number number 2 means 0, 1, 2. It will be 33.
30, no?
Yeah, 30.
Hmm. Let me just zoom it. Hmm. See, the output is going to be 30. Now, these are the inputs for a computer, which will be stored in the RAM, and then print function will process in the CPU and will give you the result. Now you tell me, if I increase the input, is the output going to be a different or some more complex?
No.
Nope. It's always going to give you the one number. Whatever you type, whatever the index you want to know, okay, it always gives you a single value, which is available over here. So any algorithm, no matter how large the input, the operation always takes the same time. So that is a constant time. Okay, if the output is one, I mean one value, and always be that, then it's a time complexity that is constant one, O of 1. Got it?
Yes.
So regardless of the input, or in other way, I can say, no matter how much input is going to get inside the algorithm, the print or the output time will always be a constant. Means it's not going to delay. Okay, in the flash, it will give you the answer. But same thing if I compare with O of n algorithm, which is the linear time. So what happened in this case? Now, what will be the output here?
Random.
Sorry,
Maybe 0, 1, 2, 3. I don't guess this.
what will be the output?
No, I don't know.
So it's simple. It's going to print all the values.
Okay.
Why? Because all the values stored in number, and
Numbers.
num is
Yeah.
iterating over numbers. So first time the value to 1 will take the 0th one. 0 is the value is 10. So print 10. Then print 20.
Oh,
Then print 30. Print 40. Only thing is it will print in the vertical like this.
yeah.
If I have to print in horizontal, I'll just comma and do int
And
and then print it. Okay. How much input I have given? 5.
5.
How much output I'm getting? 5. Right? If I increase the output, I increase the input. Now tell me how much output I'm going to get?
10.
Same 10. So
Yeah.
if I increase to 100 input, how much output will I get?
100.
100. If I increase to n input, how much output is going to get?
N.
N. So every time, depending upon the, now it depends upon the number of inputs. So no matter how much your input is giving, always the output will always relate to the input. So if the input is n, output will be n. Means n time process is going to happen. This whole loop will run for the n times. If it is 10, so 10 times this loop will be run. So 10 times execution is going to be take place. Right. So frequency is going to be 10 for. If it is n, so frequency is going to be n. That's why. And if you compare with the last one, so last one, if I increase to 10, will it take the time 10?
Yes.
No, in the O of constant one, O of 1.
Oh, O of constant. No.
Nope. It's always going to take the single one.
Single one.
So that's why you can differentiate why it is O of n. Why? Because input, if input is n, output is same as n. So you can say time grows proportionally with the input. Okay. Double the input, double the time, isn't it?
Yes.
If I go for n, it will take that much amount of time to print the n. For example, linear search, printing items, whatever you'll print, and summing. Summing basically addition. All such things, when you are involving a loop in it, it will take that much amount of time. Understood?
Yes.
Now let's come to this part. O of n square and O of log n. O of n square. Let's see that one. Usually caused by the nested loop. Very slow. Why it is slow? Let me tell you. If I take this example, now tell me what will be the output.
Which one?
For this one, for this
This
code,
one.
what will be the output?
So first will be 5. And it will be the increasing pyramid.
Increasing pyramid, right? Increasing pyramid, not pyramid, right triangle or just a triangle,
Yeah,
increasing
triangle.
triangle. Okay,
Increasing triangle.
great. So the thing is, how much time does it take? If you see, only for this loop, how many times it ran? It ran
5 times for the I.
4 times for the j.
Yeah.
For this j, let's start from the inner one always. Five times. And this 5 times run how many times?
5
Again, five
times.
times, right? So total iteration it happened 25 times,
25.
which can also be said as 5 square.
Yes.
So if I increase this to 8, now tell me how much will be the total time,
So 8 into 8.
which is 64 times.
64.
If I increase to, which is basically 8 square, right?
Yes.
If I increase to n, input is n. So what will be the output? How much time it is going to take?
N number. N
N
square.
square,
Yes.
right? N square it is going to take. So what is happening? You are giving 100,000, operation will be taking 10 lakh,
Okay.
right? So this usually happen in the nested while loop, and this is very slow. You can understand how complicated it is,
Yeah.
right? So what if I use three nested while loop? Again, if I want to print something inside this one, like this, or again J to this one. What do you think? How much time it is going to take now? And if the value is 5, let's start with the inner one. One will run up to 5 times,
Yeah.
right? And this 5 times will be running again 5 more times from the outer while loop, right?
Yes.
And this 25 times again going to run 5 more times because of the upper loop.
Yeah.
So total operation is 125, which is nothing basically the 5 cube. So if it run for n, then
Yeah.
the processing time would be n cube,
Yeah.
right? Which is very, very totally not at all acceptable in any of this one. But what happened when you go for this 2D? How can you recognize whether by seeing the output? If the output is in the 2D matrix, there has to be a use of two for loop, nested one.
Okay.
If because it is 2D, so you require the row and column both. If it is only a single row, then you do not require. Then you can say if it is single vertical or horizontal line, if it is just a vertical and horizontal line, then you can simply say that it contain only one loop.
Okay.
Okay. Oh, I'm not printing anything. Print I. If it is vertical or horizontal, only one dimension, so one loop. If it is taking two dimension, which is like this one, two dimension, then one nested loop, which is loop under loop. If it is 3D, which I cannot predict over here, I cannot show here because it is 2D screen. 3D,
Yeah.
then it is going to take n cube times.
Okay.
And that's why the gaming industry, which shows uh, the world as a 3D, where the people, even everything, GTA game you must have played, everything is 3D. There, the size of gaming software you can see it's in GBs, right?
Yes.
And their processing time for running a good game, you require a huge processor in your a good laptop, having a good processor, right?
Yes.
Why it is said? Because the operation that is going to be performed, it's going to be a huge operation. N cube, you can say very slow. Okay, only for 5 inputs, you are going to have 125 operations. So that is going to exceed the limit, and that is going to cost your this one, cost your processor. Okay, even the RAM would also get filled up. Started heating up. Your machine started getting heat up. So just take care of that one. Okay. Understood. How will
Oh,
you understand the O of n square, O of n cube? Okay.
yes.
Now the last but not the least is the O of log n. Okay. What is the
Okay.
uh, log of 8? Log 8. What is the value of log 8?
Mm. I don't know. The log ones, I'm a little bit very confusing on all of them.
Okay, no worries. So I'll show you a chart. Here it is. I asked log of 8, right? So log
Yes.
of 8 is basically 3. How 3?
Okay.
So what log does, log half the every input. So if the input
Okay.
is 8, as I said 8,
Yes.
8. So next time it is going to be half. How much? 4.
4,
Again it is going to be half, 2.
2,
And again it is going to be up to this much.
1.
Okay. Log 2 up to it is calculated. Log 2 value is 0 or 1, I guess. So that's why the value is 3. So in the similar way, if I ask you what is the log of 32?
Okay.
So next
16,
will be 16, then it will be 8, then it will be
8,
4, then it will
4,
be 2.
2.
5,
Yes.
5 operations. So if
Yes.
the input, like this is the log one, okay, not the log this, here it is. Now, if the input is how much? 64.
64.
What do you think? How much will be the output?
6.
6. So you can calculate 1, 2, 3,
2,
4,
3.
5, 6. So see, the input is 6. It's not that the operation is not happening. Operation is happening, means the data is going to be run 64 times. But
Yes.
process will happen every first 64 will go, and then again it divides the 64 into two part.
Yes.
Basically, it gives you the integer value, right? Double slash. If it
Yes.
is single slash, then it will give you the floating value. So 64 cut into half, again 32. 32 is greater than 1, again goes. So it keeps on revolving until 2. Is 2 greater than 1? Yeah. So 2 modulo 2, which is 0. So 0 is less than greater than 1? No, false. Then the loop stop. And this is the output you get. So you can see as the input increases, the output is getting solved or getting halved every time. So half of the problem in each step. So half of the problem is getting solved in every step, right? So it's again very fast even for the huge input. If the input is 1 lakh, okay, how much step it is going to take? 20 steps?
Yes.
Because 1 lakh, oh, sorry, there it's 10 lakh. So 10 lakh half is 5 lakh. Again, 5 lakh
5.
half is 2.5. So in this way, it will take 20 step. I can even show you 20 step and you will get your answer. Ooh, comma is not accepted. So within 20 steps, it is going to solve your issue.
Okay.
Okay. So that is the benefit. Now you rank which one was the best. First should be O of 1, isn't it?
Yes.
First should be O of 1. Then log n is considered to be best because it halves the
Okay.
issue that you solve, that the problem was having. And then
Yes.
O of n, depending upon the, if input is 64, output will be 64, means the processing time would take
64.
64 times. And then n log n comes into the picture, which basically looks like this. N log n is also in the picture. So if the value is 2, it is going to be take 8. This one will take 3, but this one will take 24 times. Okay, why? Because we are multiplying n. So 8 into 3 is how much? 24, right?
Yes.
So, but in case of 8, if I go for n square, what will be the value output?
64.
64. So you can see For n log n, it is 24, but for n square, it is 64. So which one is better, n log n or n square?
N log n.
N log n. That's why after O of n, we have n log n, and then we have n square. And then we have something called exponential. Exponential basically n to the power n. It means
Okay.
2 to the power 2. So if input, just imagine, even the supercomputer fails over here. If the input here is, if n is equal to, suppose 3. So according to the exponential, what will be the output? How much? N to the power n, which means 3 to the power 3, which is 27, right?
Yes.
But if it goes to 5, what will be the output? It's 5 to the power 5, which comes out to be 25. But this value exceeds dramatically. For 10, 10 to the power 10. 5 to the power, no, wrong. 5 to the power 5 is 125 actually. 10 to the power 10 is 1, and type 10 zeros after it. So you can see the output. For only 10 inputs, you are going to get, processor is going to process this much of times. I don't know how much will it be. For 7 CR, for 8, 10 CR. Oh my God, it's exceeding. We have to count in million or billion. Anyway, you understood, it's the worst. Worst of worst. Any questions?
No.
So if you see the graph, this is very important. See the graph. O of 1 is constant, so purple one is going straight. No matter how much input you are giving, okay, input sizes, suppose 4096, still you are getting the same timing, same time is going to use. Again, then the best one is O of log n. So as the input grows, its also value or the time taken by the CPU also increases, but not much. O of log n. Okay, I missed log O of n, but that's okay. After this, then O of n will come. Number of 4096, output will be 4096. Then comes n log n, and then comes your n square. Then comes your 2 to the power n, and then this one, the worst one is n to the power n. Okay, that is the exponential one, worst of ever. Any questions? You can see here as these are the input, and you can see their output corresponding to it. 1024, input is 1024, output is 1024 for O of n. For n log n, 10,000. For n square, 1,48,000. Sorry, 10,48,000. And this one is not even the supercomputer could solve this one. Okay, got it?
Yes.
So understood time complexity. That's all we are having. Yeah. Now let's jump to our space complexity. The space complexity is pretty easy compared to the time complexity. Okay. So it's basically estimation of the main memory space required in your algorithm. So how much space your algorithm is taking, that is calculated by the space complexity. For example, but before going to the example, there are basically 4 types of a space complexity that can be calculated. First is the space required to store the source code. Simple. How much your source code is taking the space. Then if you are using any variable in your source code, then that is also going to take a space. Plus your data structure process, while processing also it stores some value. So that space is also going to calculate. And space required for the stack of recursive algorithm. Recursive algorithm is, I'll come to this one later on. Recursive when a function call itself Okay. So after calling it, it also remembers the before calling function. Okay. So what are we going to do over in this lecture? These two part is not of our deal. We are not going to deal because these are pretty simple and nobody asked this one. Space, this one we'll see later on, but the main one is this one. How much your data structure is going to take space. It's not the code of data structure, it's the process of data structure in which the input and the output is stored in the main memory. And what is your main memory? Can you tell me what is the main memory here?
Memory, like the hard disk.
Not the hard disk, it's the main memory in the algorithmic, it's your RAM.
Okay.
Okay. So see, we have only two space complexity in algorithm, only two. Okay. It doesn't take much than that. So either it will be constant or either it will be O of n.
Okay.
So if it is a constant, what does it mean? What is the output of this one?
0.
Oops. Now tell me, sorry.
0. Maybe.
Sure, zero.
No. Total number, total plus number. So 10, 20, 30, 40, 50. Same.
What
10
will be the
plus
output?
20 plus 30. So 30, 60, 100, 150.
150, correct. Now, if I increase the input, is the output going to be very much complicated or is it going to be a single number?
Single number.
Single number. Even if the input increases, there is no change in the output. I mean, the process time of the output.
Yes.
Okay. So that's why it is considered to be, it's not storing anything. Every time it's taking only one value and calculating it, putting it. So what happening, the moment first the answer is 10, right? 10 is stored in the total. Then again it goes and 20. 20 plus 10, 30. So again 30 is stored. Is 10, previous 10 is still getting stored or is it getting override?
Override.
It's getting override. So here memory does not need to remember the previous value. It has to remember the current value only.
Yeah.
Okay, so it has nothing to do with the previous value because every time it is overriding. And that's why memory cost is very less, only one. Because every time it has to remember only one value. And that is the present value, not the previous one. Got it? Now, if I compare with this one, now see here. In this case, the output is, input was 10, 20, 30, 40, 50. Output is 20, 40, 60, 100, right? Now, when it calculated the first 10, okay, appended it, and when it goes for the second time, did it forget the first one? It does
Oh.
not, right?
Yes.
It remembers, put it in the storage. Why? Because it is a list.
Okay.
So every time it is putting in the list. Putting in the list in the sense of putting in the memory. So
Okay.
this 10 multiplied with 2 become 20 and 20 is inside your result. When I say inside your result, it means in your RAM. Again, next value is 20. 20 into 2, 40. 40 is again stored. Is the previous value replaced or override?
No.
No. Memory is remembering the previous value means it is store the previous value also. It is what it is doing. It is appending only, adding one by one, one after another. So in the first case, it overrides the previous value and remember only the present value. But here in the case, it remembers the previous value along with the present value. So if any algorithm that remembers the present value and the previous value, that takes the space of O of n. But if any algorithm that remembers or overrides the previous value and only remembers the current value, then that takes the time complexity as O of 1. Understood?
Yes.
So ask question to yourself again every time when you see any program, is it going to override the previous value? If it is not, then O of n. If it is, then O of 1. That's it. Space complexity. Okay, either it will store the value or it will just override the value. That's the two things you have to care about. Now let's see in case of recursive. We'll discuss this recursive in the later one. But generally what happens if you see, you tell me it falls under O of 1 or O of n. A function is calling itself. So if I give 4, so the next value is 3, 2, 1. How many times it ran? 4 times. Okay. The answer will be 4. But here we are multiplying with n into n minus 1. So 4, if what is the value of n? Whatever you provide. If it is 4, so 4 is less than equal to 1.
Yes.
No, right? 4 is not.
4 is less or equal to?
Yeah, false, no?
Yes.
We'll discuss more about this one in our future class. I'm just giving just an example. So if I'm passing over here, let's give 4. I'm calling the 4. So 4 goes over here, 4 checks 4 is less than equal to 1. No. Comes over here and return what? 4 into 3. Right? N minus 1. But in the same way it is calling also. So now the value 3 goes to n. So 3 is less than equal to 1? No. Again 3 comes here, 3 into 2. But again it is calling itself. So again 2 is less than equal to 1? No. Come over here and again it is going to call. So I'm not printing anything over here. So that's why you are not getting any output. You are not storing the value, that's fine. But every time when it is running, you can see it waits or it multiply with the previous value, isn't it?
Yes.
So is the previous value getting overridden?
No, yes.
How?
It's getting multiplied, so it will
It's
override the
getting
old value.
multiplied if I'll put a print function and put it inside this one. So it will print it every time. Runs, print, then goes back, then print. So it goes like factorial of 4, factorial of 3, factorial of 2, factorial of 1, and the base is 1. So each call waits for n frame. I mean, before 3 execute, before 4 execute, it wait for 3. Before 3 execute, it wait for 1. Right? Because this statement does not get complete unless this part is solved. Once this part is solved, then it is whole part is complete. So 4 into 3 into 2 into 1. That's how the answer comes. So what will be the value of 4 factorial?
4 into 3 into 2 into 1.
Yep, that's how it is getting calculated. Okay, so my aim was just, we'll explain this one in the later period, but the aim was like, it is remembering the past value too, right? O of n is not executed until 3 is solved. 3 is not executed until 2 is solved. 2 is not executed until 1 is solved. So when it is solved, then it will execute everything. And once it executed, it will give you the result 4 into 3, 12, 12 into 2, 24. So 24 will be your output. And that's why the space is O of n. Why? Because it is remembering the frames. Got it?
Yes.
Nothing is going override over here. Because suppose if it is override, na, then only 3 will be existed. So 3 cannot exist, only 2 will be. So always answer will be 1. If it is override, your answer will always be 1 because only 1 is getting written. Past value is going to be erased, which is not in the case. Got it?
Yeah.
We'll explain this one in the future classes. But for now, it also take O of n space. So these are the same thing, same notation. Constant logarithmic linear. You can even say instead of saying O of 1, you can say constant E of instead of O of log n, you can say it's going to take the time complexity as logarithmic. Okay. For n log n, it's linearithmic. Okay. Combination of both. And where do we use all these things? Along with the examples also you can see. Got it? Just few tips for the effective coding. Always try to avoid the nested loops. Okay. Use the set or the dist function for the lookups. Basically, if you are if you already have any set function, or if you have this, 1 or 2 line in the Excel file and you want to see, so no need to go for loop. Just run the get function. Use the function if it is available instead of the loop. Always like prefer built-in functions like sum, max, min over the manual loops. Always better one. Why? Because these are already built in. So if you'll use this one, this take very less time compared to your manual loop. And watch out for the hidden loops. Like hidden loops in the sense like when I say if I give num equal to 10, 20, okay, and I'm printing print 40 in num. So you can see, did I use loop?
No.
Nope, I'm not using loop over here. But if I run, what do you think? What will be the output?
40. So it will be 0, 1, 2, 3.
Not 40. The output is going to be true
Okay.
because it's a question, right? 40 in num, right?
Yes.
So yes, 40 in num. So how did it know? It run the loop internally.
Okay.
Okay. So always try to avoid, watch out for the hidden loops. If you use n keyword, it means it is going to take the time complexity of O of n. Why? Because internal loop is there. Got it?
Yes.
And then comes another one is the space versus time trade-off. Now, very interesting this one is. It basically says sacrifice the space for the time. Now, what does that mean? So have you heard the cache?
Yes.
So what does that do? Cache one, like if I show you the example over here as well. I'll just put let it be num underscore set equal to set. So I'm using a function set num, okay, and num I'm going to store in this one. So what does this set do? Set put everything in a cache, means it in the memory. Again, two memory is going to be used. But in this case, here loop is not going to run. Not going to run. Why? Because algorithm or the CPU already understood or compared everything that 40 exists. So it directly point from the set and give you the result. So in this case, basically in case of cache, you have what is the time complexity going to be? Since it is not going to run a loop, so it will be O of n. Oh, sorry, O of constant, O of 1. But space complexity is going to be O of n. So what happened? You have heard the word cache. That happens in the Google Chrome. Whenever you log in, your credentials are safe, isn't it? So how that part is happening? That part is happening because you are sacrificing your space. You are giving more space. Take another space, but don't run the loop. Okay, so in this way, the moment it stores everything in the temporary uh, memory, their loop need not to be run. Why? Because function already know that this number exists once it is stored in the temporary memory. Basically in the RAM itself, once it's stored in the RAM itself. So if it is already in the memory, it does not need to check with compare with every digit available, just comparing with 40 with 40 and will provide you the answer. That's why time complexity reduces and space complexity increases. So using more memory, sometimes using more memory, which is caching, make your code faster. Got it?
Yes.
And these are the same thing that we have discussed. Time complexity, space complexity, how much memory an algorithm needs. Big O notations, we describe from the big O notation. You need not to mention the big O word. Okay. And then best practices, always analyze before optimizing. So before you go and optimize your code, analyze it, see what is the time and space complexity. Once you know it, if you know you can optimize it, then go and optimize it. And that's all for this class.
Okay. Thank you.
Okay. Any questions that you are having?